A foraging honeybee will eventually discover a new food source, such as a freshly blooming flower or artificial feeder placed by a scientist. After this visit, an interesting thing happens. Over the next few minutes, many other bees arrive at the same location. They don't travel as a group. Instead, each bee finds the food source individually. How could these bees, who held no previous knowledge of this site, suddenly know precisely where the feeder was located? Is it possible that the animals communicate amongst themselves? To answer this question, Austrian biologist Carl von Frisch devised a series of experiments in the 1940s. Researchers at Georgia Tech have reproduced von Frisch's pioneering experiments using a modern observation hive. Two feeders are placed in different directions away from the hive. At each location, visiting honeybees are marked with a small spot of paint. A separate colour of paint is used at each station, so when a bee returns to the hive, it can easily be determined which feeding site it visited. Before von Frisch, other scientists had observed that returning bees tended to waggle about excitedly in a figure 8 pattern before sharing the collected pollen and nectar with their hive mates. While both sets of bees perform the classic figure 8 dance, the orientation of the dances is offset between the two groups. Bees returning from one feeder perform a rotated version of the dance done by the other bees. Incredibly, the angle of rotation precisely matches the angle between the feeding stations and the hive. This must be a clue to the mystery of how the bees are able to share information about the location of food.